In Lesson 15, we're going to extend our use of fractions in proportional relationships by using the equations and the graphs for those equations. Example 1, Mother's 10K race. Sam and his family want to show support for their mother who is going to run a 10K race, and they want to go at different locations along the race course to cheer her on, as well as meeting her at the finish line. So they need to determine how long it will take her to run the race and where she will be at various places along the course. Previously, his mother had run a 5K race with a time of 1½ hours. So we're going to assume that Sam's mother can run the same rate as the previous race in order to complete this chart. First of all, what we need to determine then is what was Sam's mother's rate during the 5K race. And we do need a little more information there. To determine her rate during the 5K race, we're going to need to divide 5K by 1½ hours. So we'll take a little space right here. And we divided 5 by 3/2, which is 1½ converted to an improper fraction. Then, again, to divide fractions, we need to use the reciprocal of the second fraction and turn it to multiplication. That will give us 10/3. We can leave it as 10/3 or convert it back. I'm going to leave it as 10/3 for right now, meaning that our rate then is 10 thirds kilometers per hour. Since they want to stop at various locations, I'm going to put the 1 hour rate in the second position because we might want to know how much for 1/2 of an hour. Okay, let's go back to 1/2 of an hour. And at 1/2 of an hour, she should be at the 5/3 mark. 1/2 of 10/3 is 5/3. Continuing with the same rate at 1½ hours, she would be at 10/3 times 1½ which will convert into an improper fraction as well. 3/2, and that's 30/6, which simplifies to 5. At the 2 hour mark, she would be at 10/3 times 2, which is 20/3, and simplified, that would be 6 2/3. 6 2/3 kilometers. At the 2½ hour mark, again, she would be at 10/3 times 2½, which as an improper fraction is 5/2. When we do the multiplication, it's 25/3, and simplified is 8 1/3. And finally, at the 3 hour mark, she'll be at 10/3 times 3, which would be 30/3, and simplified is the 10K mark. So that will be the end of her race at the 3 hour point. After creating our ordered pairs, we're now going to have to graph those ordered pairs on the already marked graph. Please remember, when you do your own graph, you need to label both axes in words. The x-axis is time in hours, the y-axis is kilometers run, and then you need to find the equal intervals that you're going to label each axis by as well. You'll notice that the time in hours is marked in half-hour increments because that's how we calculated, and the kilometers run are marked in by ones because typically we want to know where the 1 kilometer, each full kilometer space is. So we'll go back in at the 1/2 hour mark. She should have run 5/3, which is 1 2/3. So we'll approximate where that is on the graph, and we'll put a point. At the 1 hour mark, she should be at 10/3, which is 3 1/3. And again, we will approximate that point on the graph. At the 1.5 hour mark, she should be at 5. At the 2 hour mark, she'll be at 6 2/3. At the 2.5 hour mark, she'll be at 8 1/3. And at the 3 hour mark, she will be at the 10. At this point, you need to answer some questions about what you notice about the graph. And I hope at this point that you should notice that it is graphing a proportional relationship because it is a straight line and it will pass directly through 0, 0, the origin. The connection between the table and the graph is, of course, that the time in hours is on the horizontal axis and the kilometers run is on the vertical axis. The coordinates of the points on the line are the same as the pairs of numbers in the table. That's a given. And question C asks what the point 2, 6 2/3 represents. In words, the point 2, 6 2/3 represents at the 2 hour mark, she has traveled 6 2/3 kilometers. Example 2 is about organic cooking. And after taking a cooking class, you decide to try out your new cooking skills, preparing a meal for your family. You've chosen a recipe that uses an organic mushroom mix as the main ingredient. So we're going to use the graph to complete the table and answer the questions. At 0, 0, which would represent the first part of a proportional relationship, second part being a straight line. So we know first and foremost that this is a proportional relationship. We have the point 0, 0, and then they've given us the values 1/2 pound and 4. At 1/2 pound, you can see that it crosses the grid exactly at 4. So that rate will be easy for us to calculate. We're going to calculate 4 divided by 1/2, y divided by x. And so 4 divided by 1/2 would be 4/1 times the reciprocal of 1/2, which is 2/1, which will give us 8/1. Our rate is 8. Knowing that information, now we can fill in the rest of the chart. If x is 1, 8 times 1, which is our rate, times the x value, would make the cost 8. And we have one other missing value where we have the cost and we're looking for the x value. So if we know the y, we need to divide by 8 in order to get back to our x value. 16 divided by 8 is 2. We answer several questions. The relationship is, of course, proportional. We talked about that previously. It passes through the origin and it is a straight line. The unit rate for cost per pound we calculated up here, and the unit rate then is $8 for 1 pound. The equation to model the data would be 8 times W, W signifying the weight, equals C. Or if we want to use X and Y, it would be 8 times X equals Y. The ordered pair that represents the unit rate would be our ordered pair 1, 8. And that ordered pair means that for every pound of mushrooms, the cost is $8. Following that same pattern, the ordered pair 216 would mean for every 2 pounds of mushrooms, the cost is $16. Then, if we could spend $10 on mushrooms, how many pounds could you buy? We would need to take that cost and divide it by the $8 per pound that is our rate. So if we take 10 and divide it by 8, we would get 1 2/8, which simplifies to 1 1/4. Pounds. Make sure you label. And the cost of 30 pounds of mushrooms, we would calculate by multiplying we'll do it up here. By multiplying 30 times 8, since 8 is our rate, and that cost would be $240. Remember, proportional relationships can be represented through graphs, tables, equations, diagrams, and even verbal descriptions. And in a proportional relationship with ratios and rates involving fractions, the graph can give a visual display of all the values in the proportional relationship, especially the quantities that fall between integer values.